Hello and welcome to the video about the analysis dedicated to Titanic file. So in this assignment about Titanic, you are asked to use the data set provided with JUMP in its standard sample data library, and the file contains information on 2201 Titanic's passengers. So for every passenger we keep 4 pieces of data, so 4 columns. Each record is organized in 4 columns. First of all, whether or not the passenger survived, so that's one of them. Another is what class the passenger was traveling, first, second, third, or crew. Then age. Now the age is classified in just 2 categories. It can be adult or a child. However the division was done, each record is one of these 2, child or adult. And then gender, male versus female. So you are asked to partition the data and perform the classification analysis, classification tree. So let's get started. First of all, you need to go to the menu Help and Sample Data Library. It will open up the folder with all files provided by default with JUMP. So scroll down and closer to the bottom you will see the file Titanic JUMP. Let's go ahead and open that. So just like was discussed, file consists of 2201 observation, and each observation has class, age, sex, and survived yes or no about that specific passenger. Alright, so let's actually turn our attention to the way how we classify different tools and techniques within data analytics. First of all data analytical methods are subdivided into 2 broad categories. They can be either supervised or unsupervised. You're dealing with supervised methods if you're trying to model certain variable or target response. So in our case, we're trying to predict whether or not the passenger with a specific characteristics would survive or not. So we do have a target, and that target is a categorical response contained in the column survived, yes or no. Alright, and also your predictors, the rest of the variables basically, are all categorical because we're dealing with class of the passenger, first, second, third, or crew. That's categorical. Age, that's not a number but rather a category, adult or a child, and also sex, which is male or a female. So all of our variables, target and also predictors, they're categorical. So one of the suitable techniques in the data analytics package is classification tree, and that's precisely what we're going to do with this data set. So let's go back to the data set. First of all, you're instructed to create a partition to split the original data set into 3 subsets. One of them is going to be training, that's 40%, another is validation, also 40%, and testing, where we evaluate the how good the model is that we're going to build. That's a testing set. So how do we split or partition our data set? We go to Analyze, Predictive Modeling, and Make Validation Column. Alright, so this window tells you that there are 2201 observation. My training set, as I was instructed, is going to be 40%, validation 40%, and testing 20%, the rest of them. Now you're also instructed to create fixed random partitioning using the seed number of 100. So when I click that button, fixed random partitioning, it will split in a certain random way all of my entries, all of my data points. Each one of them is going to be one of the 3: test, training, or validation. And because you're using the same seed, everybody should receive the same split into testing, training, and validation. Okay, so now let's go ahead and build a model. We need to go to the menu Analyze, Predictive Modeling, and Partition, Recursive Partitioning. And our X or Y response is whether or not the passenger survived. That's what we're trying to predict. The predictors are class, age, and sex, right there. and the validation column, the one that we're going to use to build a model and then validate and see how it's doing. That's my validation. It should go right here. Now if I click OK, here is my initial window. Well, you can see that some of the dots are grayed out, most of them grayed out, and some are black. That's because somehow they're selected. So let's deselect everything. And I go back, so all the dots are black. So now I can color them. And one of the questions asks you how many observations are in the training set. We're looking at the training set right now, because that's the set that is used to build the, to grow the tree. So because we specified, 40% of my 2200 observations, training set right there contains 880 points. And you can see that in the training set, the majority of points are red. In fact, let's go ahead and go to the big red button, red triangle, and display split counts. And will also not only show not only counts but also split probabilities. You can see that people with response no means they didn't survive represent 67% of my training set, 880. The rest of them, survivors, they represent close to 33%. So these are blue points. Okay, so now I'm going to go ahead and build the model. I can do it manually by clicking split, and it just recursively splits the my original data set into subsets and then further down. But instead of that, I'm going to cut it back to the original set. Instead of that, I'm going to perform the splitting automatically. So if I click on the Go button, it gives me the resulting tree. And you can see the tree is pretty large, right? So let's take a look how many splits are in the optimal tree. It looks like, here's the size of my optimal tree, right? That's where the splitting was done, finished. So right now I'm looking at 8 splits. That's the depth of my tree. Now let's see, 1, 2, 3, 4, 5, 6, 7, and then there's 8 right there. Yeah, so there are 8 splits. Okay, let's go ahead and keep analyzing the model. Next question asks us to evaluate the model accuracy. So model accuracy is evaluated in a number of ways. One way to evaluate model accuracy is look at the R squared. R squared, the interpretation of R squared is, generally speaking, it gives you the percentage of variability in your response variable, which means whether or not passengers survived, which is explained by and attributed to variability in your predictor variables. In other words, in this model we're assuming that whether or not the passenger survived or died was affected by the gender, male, female, the age, was it adult versus child, and also the class the passenger was traveling. So each passenger, probably, well, most of them anyway, they had different values of these 3 predictor variables. As a result of that, some of them died, some of them didn't. So there was a variability among passengers, and probably, to a certain degree, that variability was explained by the fact that they had different genders, they traveled different class, and they had different ages. So by looking at this R squared, I can pretty much tell that R squared is 25, which is the way to interpret that is 25% of variability in response variable survival, yes or no, was explained by the fact that different passengers were traveling different classes at different ages and different genders. Now the R squared measure is, you can see it right here actually, it's anywhere between 0 and 1. 0 being the worst, means that your model doesn't explain anything in the target variable, and 1 being the best, meaning that your model explains what happens in the target variable perfectly. So naturally you want to be as close to 1 as possible, which is not the case with my model. Its R squared is only 25, which means that only 25% of responses yes and no are explained by different genders, different classes of passengers, and different ages. So all things considered, altogether, I'm looking at not a very good predictive model. Okay. So now let's take a look at another question. Which predictor variables contribute the most to the model? In order to answer that, I need to go ahead and click on this red triangle and display column contributions. Go ahead and display column contributions, and here you can see the ranking of the independent predictor variables, how they contribute to the model accuracy. Okay, how much of the model accuracy they explain. So you can see that the strongest predictor of the survival, whether or not people survived, was actually sex. So gender, male, female, was the strongest variable that could predict if a person would survive or drown. The next best variable after gender was class of the passenger, first, second, third, or crew, and age was not a strong predictor. So it did contribute to the model, but its contribution was not the greatest. So if I would have to, if somebody would ask me what's the strongest variable that would predict who will survive and who will die, I'd have to say gender, right? Difference between males and females in terms of who survived and who died was the greatest in the model. Okay, so gender was the strongest predictor who will survive and who will die. Now, next question asks me to construct a confusion matrix and report misclassification rate for training, validation, and testing. So in order to do that, again, I go to the red triangle menu, and I go ahead and show feed details. So when you show feed details, you have confusion matrix. In fact, 3 of them, because you remember our model was trained on the training set, and it was pruned back. And you can see that actually it was pruned back from 10 splits down to 8, right, on the validation set. And after that, we independently evaluated the performance of the model on the testing set just to see how good is the accuracy. So misclassification, what does that mean? Well, let's take a look at the training set. If you remember, training set, let's scroll up, training set contained 880 observations. Out of these 880 observations, 540 were classified as non-survivors. Originally, actually, 540 people out of these 880 drowned, and our model correctly predicted that they will drown. 141, they survived, and our model correctly predicted that they would survive. But there was a substantial misclassification. Misclassification are things that you see off diagonal. So people who actually survived, but we predicted that they would die, and people who died, but we predicted using that model that they would survive. So either one of these 2 cases, yes predicted no, or no predicted yes, they're misclassification. So altogether in the training set, I'm looking at 199 observations that were misclassified out of 880 original. That gives me the misclassification rate of 22.61%. So in other words, close to 23% of observations in my training set were incorrectly classified by my model. In the validation set, the accuracy was and this is another, by the way, way to evaluate model accuracy, right? Obviously, you want misclassification rate to be as close as possible to 0, right? That means that none of your observations are classified incorrectly, and your model performs ideally. The closer it is to 1, the worse we are, pretty much like with R². So in the validation set, the accuracy or misclassification rate was also pretty close to that, 22.4%, and on my testing data it was 22%. So again, let's take another look of how accurate is the model. Our R² showed that only 25% of survivals, or people who drowned, they were correctly predicted. It's not quite correct, actually, interpretation. The variability from person to person in terms of whether they survived or died was explained, only 25% of this variability was explained by variability in the gender, class, and age. So it was not a very decent model. In fact, model is very weak. So anything below, let's say 30%, if r squared less than 30%, then this is a low accuracy model. So that's a pretty bad model. According to my misclassification rate, I get the same result pretty much. 23% of my observations were misclassified. That's not a great result, really. So that's another indication that the model is not very decent, right? So therefore, my confusion matrix does actually support the conclusion that I did before from the r squared. Model has pretty low accuracy, but we can use the model anyway, right? Let's go ahead and do that. So, for example, let's say I have another passenger who traveled on Titanic, right? Who was a female. She was an adult, and she was traveling second class. So if I knew that information about the passenger, what would be my prediction? Would she survive or would she die as a result of the crash? So what I have to do really in order to deploy that model and make prediction on other unobserved data is this. I have to go into the red triangle menu and then save column, and I have to go ahead and save prediction formula. So in the save prediction formula, yeah, and somebody calls on the phone in the middle of the video, that's not good. All right, again, save prediction, save columns, save prediction formula, and nothing happens. Well, that's because
100th day of school. Our SCA has
I already saved the formula into my original data file. And you can see that it created on the top of that, well, I did it twice apparently. It created on the top of that three columns actually. Probability of that specific person to survive. That survival is no, that's drowning, right? Probability to survive, that's 1 minus that. And how we're going to classify that observation. So if you remember, default cutoff point for the classification trees are 0.5, right? So this one, for example, we calculated the probability of not surviving as 0.66. It's above 0.5, so therefore we're going to say no, that person will likely not survive. So if I have a new observation that I have to classify, all I have to do is scroll back down the very bottom, just like that, and she traveled, that person, right, she traveled second class, so I'm going to say second class, and once I actually do that, you can see that immediately the model starts predicting, right? So it says based on just that, the fact that she was traveling second class, she'll likely not survive. Okay, well, let's keep going. Maybe we'll have a different answer when everything is entered. Adult, female, right? I'll still no. And female, yes. Okay, so now basically that's how we apply the formula that you saved in this prediction column, right? So therefore, if there was a passenger who is female adult traveling second class, likely she would survive. The probability of survival for her would be 83%, the probability of not surviving 16%. But that pretty much concludes the video that explains how to build the regression tree for that specific example, Titanic, how to evaluate its accuracy, and how to use it for the prediction of unobserved, for classification of unobserved data. Okay.